Might have a few more people flowing in as we get started, so we might start the discussion now. Start with intros here. Can everyone hear me okay? Loud and clear. Now we've got, so I'm Sam from Farmlab, and we've got Dr. Lynn Mcdonald here today from CSIRO. So I'm just going to introduce Lynn really quickly. We've got Flora in here as well to take some questions. And as usual, we'll be recording the webinar and posting it online because there's always some really interesting things that come up in these webinars that relate to soil, and obviously with harvest on at the moment, I know there's probably a few people out there that wanted to make it and probably can't. So yeah, so look, without further ado, let's crack into it. So yeah, joining me today is Dr. Lynn Mcdonald. Lynn is a CSIRO researcher and team leader of organic matter function and isotope traces. Diverse team of soil scientists based in Adelaide and Canberra. They develop innovative management and supply chain solutions through understanding carbon and nutrient transformations in soils and tracing the fate of elements through agricultural commodities. That's a mouthful. We're here to talk to Lynn today about diagnosing and managing constraints in sandy soils, a current GRDC project that Lynn is leading, and I'm sure you're all interested to hear more in. So yeah, so Lynn, hopefully I got most of that right.
Yes, it's a fairly big mouthful for you, Sam, so yeah, nice work.
Yeah, good, Lynn. Well, look, so we might just start today with a bit of an overview of the GRDC project, and then we can sort of segue into subsoil constraints, soil carbon, all the really exciting things that the Farmlab community care about and want to know more on. So, look, I'll let you take it away. Go ahead if you want to share your screen there. Lynn's got a brief presentation, and then just for everyone involved in the webinar, we do try to make this as participatory as possible. So we'll get to questions at the end. You can either pop questions in the chat and or just fire them away when we open to questions. So go ahead, Lynn.
So hopefully my screen is sharing. I have kept it fairly short on the slides today because I guess I'm hoping for more discussion than anything else. But I do have to acknowledge that the GRDC Sandy Soils Initiative is a large programme of research, and it wouldn't be possible without our university and state government partners, as well as engagement across the farming systems groups, which has been a really valuable component to the project. So the project is looking to improve both the diagnosis and the management of primary constraints to poor crop water use in sandy soils across the low to medium rainfall zone. And the project came about because there was a lot of discussion around the unused water at harvest in sandy soil systems. And how we could get better use of that water to flow through to yield gains. And there was a real lack of understanding as to what those constraints, what the primary constraints were to root growth and water use, and also how to target those constraints in terms of management. So the sandy soils region across the southern region is broad, and we have a large variety of different sand types. So across these different sand types, we have a whole range of different constraints that come into play. On the surface, it might be water repellence. And then as we go down the profile, there's typically poor water holding capacity, poor nutrient retention, as well as hard layers within the soil, and deeper down there may be acidity issues or pH issues, both acid and alkali, and also potential sodic layers at depth. So it's a real mixture of different constraints that come into play. And at the time, there'd been growing interest in some of the deep amelioration approaches to address the constraints at the time. The project does look at both amelioration, so intensive deep tillage type strategies, as well as annual mitigation strategies that are achieved through cedar practice. But today I am going to concentrate on the amelioration side of things. But broader across the project, we are looking to identify which sandy soil environments are worth investing these amelioration approaches in. So a quick bit of geography for everyone. Hopefully people will be able to identify one of our project sites near them. We do stretch all the way from the Eyre Peninsula to southwestern New South Wales. And in 2006, there was very mixed attitudes across the region, and in places reluctance to ameliorate based on past bad experiences. Fast forward to 2019, and we have a fairly big appetite, particularly for ripping, with a certain attitude of bigger, deeper, better. But that's not the case everywhere. And key to understanding where is not only which constraints are at play, but also an understanding of what the yield gap across the low to medium rainfall is, because essentially that's what we're chasing in order to ensure that there's return on investment from the intensive strategies.
So just on this, Lynn, just on this slide, so what you're saying here across here, the yield gap is an average of 2 to 3 tonnes per hectare?
We have estimated it at the moment, and I would say that yield gap estimates tend to be a bit rubbery around the edges. But yes, based on characterisation of the water, the plant available water, then we estimate a yield gap of 2 to 3 tonnes across the region. Due to
subsoil constraints?
Due to a variety of constraints. So in sandy soils, water repellence on the surface also comes into play, as well as the subsoil issues, yes.
Yep, fantastic, wow.
So at the beginning of the project as well, we had an inkling that perhaps the nutritional aspects of sandy soils were not the only issue at play, although there had been lots of discussion around how to improve nutrient supply in these sands, because obviously they're inherently low fertility. But very early in the project, we gathered a lot of data that demonstrated the physical constraints within sandy soils are widespread, and they are probably stronger than we had anticipated. So from the data we've collected, we can fairly reliably say that most sands in the southern region will have some type of physical constraint within 20 centimetres that's limiting root growth, and that can extend fairly deep into the profile, 60 centimetres or more. And having knowledge of what this physical constraint looks like helps us target the amelioration approaches. So anything above the red line here would be indicative of limited root growth due to that physical constraint.
Fantastic.
The physical constraints are arising not just from compaction, but from a hard setting type behaviour or cementing behaviour that seems to occur at different depths within different sand types. And we have added to the project, we have a postdoc component that's looking to understand that cementing behaviour and how it flows through impacting crop growth through the season. I just wanted to demonstrate, I'm sure many of you have seen ripping in operation, but this is a little video clip of just how disruptive these types of approaches can be. So the ripper tines there are probably going down to about 35, 40 centimetres. We have a trial peg just gone through. but it does demonstrate the extent to which there's uplift from the ripping process. And of course, we're aiming to shatter those areas of high soil strength through these types of approaches.
And just quickly here, Lynn, cost. I mean, this isn't a cheap exercise by any means, is it? Deep ripping.
It's not. So the different amelioration approaches vary depending on exactly what's being used and how it's being targeted. We are gathering information to conduct economic analysis, and typically we have a sort of straight ripping operation estimated to cost about $60 to $90 per hectare. Although if you start adding various different amendments along with that, or if you aim deeper, then the costs will obviously go up.
Yeah, interesting. It's kind of, I guess it's kind of like surgery, right? I mean, if you go to the doctor, they'll always try and get to the introduced measures, preventative measures, before you ever have to go and get a surgery. And I mean, it's a similar thing. You want to be implementing measures over time that are gonna reduce your risk or probability that you're gonna have to do deep ripping in the future. And I think that's something we'll get to in a minute. I'll let you go on, but
yes,
I think it is interesting.
I think that's a very, very good point. And also treatment after a rip to ensure the longevity of effect is a big consideration as well. So once we've opened up that soil, we want to be confident that it's going to last and manage the system so that it does last as long as possible. So this is just a quick snapshot across a large number of our trials to demonstrate the type of yield responses that we are seeing. The top graph represents the control yield versus a deep tillage event, which we have included a variety here. So ripping from 30 centimeters to beyond 50 centimeters, or ripping plus inclusion. And I also have spaded treatments to 30 centimeters within this graph. But the main point is that anything above this 1-to-1 line is an increase in yield. And typically we have seen between about 0.5 to 1 tons on average. And that does vary depending on the type of amelioration treatment that we are looking at. So typically a deeper rip will bring us better gains. However, that does depend on exactly what that physical constraint looks like down the profile. You'll also notice some negative responses, and they are typically not in the first year, but seem to be associated with the very dry years where there's perhaps not the moisture refill on the profile to take advantage of. The second graph demonstrates what can be achieved above and beyond a physical amelioration alone. So I've got the physical amelioration on the x-axis and plus some type of amendment on the y. And those amendments that we've used are typically things like increased fertilizer inputs, chicken litter where it's available in the different regions, or a nitrogen-rich hay material. And on the whole, although results are fairly variable, but perhaps the most reliable results we've seen are around chicken litter. So where we have boosted the nutrition available to the plant, and this is indicated in the red line, we tend to have about another 5 tons per hectare gain.
So this is really interesting, and I'll just because we put something out on Twitter and LinkedIn yesterday, quote from one of your papers there, Lynn, one of the papers that you co-authored around how a 0.5% decline in soil organic carbon in a 10 centimetre layer of soil with a bulk density of 1.3 grams per centimetre cubed equates to a loss of 540 kilos of nitrogen per hectare. And I just thought that was relevant to bring up here, especially where you're introducing using chicken manure to increase this, is the impact that carbon loss and carbon improvement has on nutrients, holding nutrient holdings and retaining nutrient levels. So potential fertilizer savings in the future there, which is absolutely fascinating.
Yes, I think there has been a lot of interest in the chicken litter aspect, and a lot of that gain does come from the nutrition that it supplies, obviously, but it also comes down to some of the timing of release of that material, and perhaps also some of the micronutrients that are in there. There is probably a caution in the sandy soil environment around the use of surface application of chicken litter, because we do have trial results that demonstrate an increase in water repellence several years after the chicken litter has been applied. So we do need to keep an eye on exactly how much chicken litter is added and what subsequent effects there might be on the repellency aspect.
Are those correlated with are those correlated with specific soils, Lynn? How can our listeners avoid avoid that?
So it was correlated with a very dry start, which is typically when water repellence tends to express itself. It did happen about 4 years after the application of chicken litter, so it does demonstrate that some of that, the waxier type material is left behind. It was in a trial that had high rates of chicken litter application. So there were 2 treatments, 5 tonnes and 20 tonnes. And the 20 tonnes was particularly poor, which would not be a typical management practice that farmers would implement. They'd more likely be applying perhaps down at the 2 to 7 tonne, depending on the yield target that's being aimed for.
Yeah, great.
The other tactic there is to actually mix the chicken litter or to deep place it into the system. But we're still looking at whether or not the economics of some of that adds up.
Fantastic.
So the other point here, I think, is we do have an awful lot more of these treatments sit below that one-to-one line, which indicates that there are risks of negative impact of adding some of these amendments. And we think that that relates to early biomass production, where we have a lot of biomass and not the rainfall at the end of the season to actually finish the crop. So there's a balancing act to be had around looking for improvements above and beyond a physical amelioration alone. So really in the southern region, in fact, across many parts of Australia, the adoption of conservation agricultural approaches have been very well taken up. And these practices tend to look to minimise soil disturbance, increase permanent soil cover, and use rotation to improve the systems. And in some ways, the strategic deep tillage is a little bit counterintuitive to this because it is a big disruption. But I think we have to remember that it is an infrequent corrective therapy where we're looking to address specific constraints and then manage the system going forward to maintain those improvements and get the bigger crops and the bigger biomass to flow back through the system. So key to understanding how to manage these systems is really understanding the soil constraints and where they occur within the profile. I think oftentimes we talk about soil health in a fairly generic manner, but to me, we really need to understand whether we're working in a preventative type case, or whether there are acute and chronic issues within the soil that require more intensive approaches to ameliorate them and then move forward from that. And of course, if we can address our soil constraints and improve productivity or plant biomass production in some of our systems, then that's the first step in actually looking to build soil organic matter and improve the resilience of the systems. I would probably also mention here that there's always a big focus on the carbon within soil organic matter. And accumulating soil carbon for sequestration purposes. However, oftentimes to get the function we want from soil organic matter, it does need to decompose. So we're looking at long-term type approaches that have building phases, and then we use the value of soil organic matter. So it's not only about the carbon stock per se, but it's about the flow through the system. And that is my introduction for today's discussion.
Fantastic, Lynn. That was incredibly interesting. All right, well, I might start with a few quick questions. I've got about 1,000 following that presentation. And bear in mind, everyone, that we'll open up to the audience for questions in a second. As well. So please feel free to chuck any questions you've got in the chat and or stop and yell out if you've got any. So I'm going to start because I can, because I'm the host and I get to. When it comes to constraints, let's just keen to talk about diagnosis and how do farmers and agronomists diagnose and identify which constraints they need to address first. A few things here. There's soil testing, obviously. There's visual factors. Is there any remotely sensed data that you've found could be used to identify these constraints here, Lynn?
So in terms of remote diagnosis, we haven't cracked that one yet, and it will be a really valuable one because it also ties into the spatial aspects of where we need to start and stop these amelioration practices. But typically the approach that we've taken for setting up our research trials is to identify areas that are underperforming. And we can do that from whether it be yield maps or NDVI through the season. And then it's in combination with some soil sampling to understand what's going on within the profile in the underperforming area.
Sure. How deep should our listeners be soil sampling? I mean, are we looking down to a metre? You spoke about the constraints between 20 and 60 centimetres there, Lynn. What are your thoughts?
So, yeah, the framework that we have used to discuss the constraints context is the first thing that we need to do is think about getting, maximising opportunity for moisture to get into sandy soils. So in the sandy soils context, the water repellency comes into play quite quickly because that will prevent good soil moisture within the profile. And subsequently, we are looking to move down the profile and identify or eliminate specific constraints. And to me, one of the really important things to eliminate is pH. Or acidity issues, and that can be done through pH dyes. It's probably easier to do it on a dye basis as opposed to a soil test. Soil testing, we typically do 0 to 10, whereas you may have an acidity band within the topsoil that's finer than that. So the pH dye allows you to visualize whether or not there's something to look at there. If you did use the dye type methods, then you'd probably want to follow up to get a quantification of that pH, because that will then inform the amount of lime that needs to be added.
Really interesting. Yeah, I mean, you know, it really does come down to that ground truthing and to actually getting out there and seeing what's going on beneath the soil. You know, I certainly love using technology where we can, and you know, remotely sense data is the you know, the hot new thing in agriculture. But when it comes to diagnosing subsoil constraints and any soil constraints, really, you know, getting out there into the paddock, it can't be beaten from a diagnosis perspective. It's interesting. It's very interesting.
EM mapping can also help, but again, there's a need to dig the holes and do the sampling to really confirm what's going on.
Yeah, great. Now, I don't know if any of our listeners are aware, but yesterday was World Fertiliser Day. So I might touch on fertilisers, chicken litter. I just wondering, in terms of your research, Lynn, you know, what have you found works really well and why? So, you know, talking about improving soil fertility as well as soil carbon, the long-term versus short-term effects, and you know, if we could just have a bit of a discussion around that, I think would be quite interesting.
So in terms of the nutrient supply side, if we accept that a lot of these deep sandy soils have the physical constraint, then and we address that through an amelioration approach, then it then offers the opportunity to get material at the same time as ameliorating into the profile. So we have a trial led by Mallee Sustainable Farming, which has looked at different types of amendments. And we've looked at the C to N ratio of the amendments to guide how we think the crop will respond. So essentially we use the C to N ratio to indicate how much nitrogen mineralization we expect.
So let's just dive into the C to N ratio. So we see this coming up quite a bit with soil testing with our users. What can you just give us give somebody that has no clue, i.e. me, a bit of a background into, all right, what are we looking for? We're looking for a high ratio, a low ratio. What's the just break that down a bit for us.
So there's, yes, soil organic matter will typically have a carbon to nitrogen ratio of around about 12. And these different amendments range a fair bit around that. It's chicken litter in particular is very variable in its C to N ratio, but there is perhaps a sweet spot in some ways around that ratio in terms of mineralization and immobilization. So if we have a residue with a very high carbon content like oaten hay or cereal hay, then it will tend to immobilize nitrogen. And that means that the microbial community needs nitrogen from elsewhere in order to use it. So the microbial community will be locking up nitrogen from the soil when we add oaten hay. And that was demonstrated in the trial. However, we also have to remember that that is locked up for later in the season or subsequent seasons. Whereas
so 12 is good. We don't want higher because it locks up nitrogen.
And 12 is the C10 ratio of soil, whereas amendments will range more widely. I think, if I remember correctly, then we went to optimize the C to N ratio of a mixed residue input at around about 22. And we thought that would not release a huge amount of nitrogen up front, and it would be slower decomposition for later in the season.
And was it? Are
In
the
the
results
first,
available? Yeah.
so in the first year, yes. So in the first year, the C to N ratio is a very good predictor of the yield benefits that we saw. And the higher C to N ratio of the chicken litter supported the biggest crop production. However, the real aim of that trial was to look at how that performs over multiple years, because it affects the nitrogen availability for the subsequent seasons. So we still have to disentangle the subsequent years, but the first year very predictable. Second year we were hit by drought, so it wasn't particularly good season to disentangle that, but we are following it through for 5 years.
Fantastic. I just want to touch on longevity now of the deep ripping, but also, you know, just looking at the long term. I guess keeping soil in a relatively fertile, sort of productive fashion over the long run. So, I mean, firstly, is there anything farmers can do to avoid deep ripping in the future? Any management practices they can instigate to avoid that high cost of deep ripping if they have if there's nothing wrong with the soil noticeably at the moment, and then let's say people do have to go down the deep ripping path. What is how long does that last, and what are the effects, and then what do you have to do to then manage soil?
So I think in terms of managing the system to prevent the high soil strength and the compaction type issues, to some extent sands they have that nature and tendency to become fairly tightly packed. So there's a certain amount of natural settling and hardening will happen, but controlled traffic certainly, and rotation to ensure that we are getting deep rooting crops into the profile to keep structural aspects in play. But controlled traffic would certainly be one aspect, and particularly after ripping, we want to minimise the trafficking on particularly the just ripped system.
Yep, fantastic. Do we have any questions from the audience? Does anyone want to yell out or chuck them in the chat? No, that's all right. I thought. Yep.
No questions yet.
Go for it. Yes. No questions.
No.
No, cool. Sorry, we had a few people going off mute. I thought we might have some there. Okay, cool. So Lynn, just back to that point there. So that's sort of prevention as well as sort of ongoing soil management post deep ripping there, especially as well. Yep, fantastic.
Yes, and the other important aspect, I guess, post deep ripping is to ensure that we are feeding the crop, whether it be through fertilizers or other amendments to maximize the potential.
Yeah, fantastic. I just had a question from Steph. Thanks, Steph. Does the addition of mycorrhizal fungi extend the depth of cereal crops? So I guess, so how have you dealt with mycorrhizal fungi before, and how deep will they extend to?
So we haven't specifically looked at mycorrhizal fungi within these.
Fruits, yeah, no, I get it, Steph. That's good. Yep. Steph's just just explain that's the depth of the crop root.
So yes, I don't know at this stage. I think mycorrhizal fungi, the hyphae, can extend extensively over fairly large distances, but I don't know if they tend to go laterally or down the profile.
And I can probably add to that, Steph. The people to ask, if you know of Guy Webb and Soil Sequest or the Soil Carbon Co. It's their sort of commercial arm. They're doing a lot of work in inoculating seeds with mycorrhizal fungi and to help sequester carbon deep into the profile. So there is a lot of work starting to happen in that space. But yeah, really interesting question. Yep, cool. Have we got any more on that front? We might delve into.
I think if we're able to get the deeper rooting capacity, so at the beginning of this project, we were digging various profiles on underperforming sands, and the roots were going 20, 25, maybe 30 centimeters. But if we can get the deeper rooting capacity, then it will take soil biology deeper into the profile, because the roots will be supplying root exudates, so simple sugars and amino acids that the microbial community can use. And the mycorrhiza fungi, of course, are a symbiotic relationship. So having the roots deeper makes sense that the mycorrhiza will also be deeper within the profile.
Yeah, fantastic. Just a broad question, Lynn. So quite often we've dealt with toxicity in relation to subsoil constraints and how it impacts available water capacity. Things like boron. When we're in New England, we do get some aluminium at depth, but we don't really have a sandy soil up here. But yeah, down south, mallee, boron, acidicity, other things. Should we manage these soils the same way? As in, is the solution, can we deep rip these soils? If we've got a toxicity problem down at 60 centimetres, is deep ripping still the way to go in those?
I wouldn't be advising deep ripping into a toxic layer. So if you've got boron at a specific depth, then you don't really want to be ripping into it, because with ripping there is a certain amount of uplift as well. So you might actually be raising that issue shallower in the profile.
So I guess it's one of the considerations you need to look at if you're facing one of those subsoil constraints. Considering deep ripping, well, you don't want to bring toxicity to the surface. That's probably the last thing you want to do, right?
Yes, I think whether it be boron or sodic layers or even acid layers, we do have a couple of trials within this project that have been conducted on sands that do have acidity issues. And typically a physical amelioration alone will not improve the situation at all, because it's not addressing the primary constraint.
Yep, fantastic. We're getting to the end of our webinar session today. So just wanted to see if there's anything else that you wanted to mention in relation to subsoil constraints or ongoing soil management. I guess our, Farmlab are all about sort of better soil management. We're trying to provide our community with some educational insights into how to improve soil across the varying sort of soil types that we have here in Australia at the moment. Most of our listeners are from Australia. Is there anything else you want to add in terms of, helping probably more in the sandy soil space, people get better soil management? And before we move to that, we might just answer this question from Brad Bennett. So Brad's just sent through a quick question before I fire you with the last one there, Lynn. Would a more aggressive ripping process with more soil mixing potentially extend the length of the rip effect, so disrupt the cementing nature?
What was that?
Yep. Go for it, Lynn.
So a more disruptive ripping, I think it depends to the extent to which you've got the shattering between the ripping tines. And I think, yeah, Brad will be well on top of ripping setup, having done a great demonstration day. Is that a couple of years already ago, Brad? With different ripper types. I guess there's a balance between getting a more aggressive ripping that might disrupt more so the surface soil and whether or not there's a particularly high erosion risk where that's being conducted. It's probably a bit of a balance. In terms of the cementing layers, we are hoping that Rodrigo, our postdoc, is going to identify why or what's contributing to that cementing behaviour. And at that stage, we should be able to identify whether or not there are any amendments that will appropriately address that going forward. The amount of mixing, I think certainly the characteristics within that cementing layer are different. So if we can dilute it and mix it up, whether that's through spading or a intermediate or aggressive ripping, is a possibility, but I would really love to know what's causing it before we look at how we then target that issue.
Yep. Thanks, Lynn.
Good question, Brad, and good answer, Lynn. That was great. So just to round it off now. So you know, we try and offer, I guess, our listeners and attendees, I guess, a good insight into how to better manage soil. What advice, just general broad advice throughout your career have you found in terms of what is the best, you know, what is the number one thing you would recommend our listeners do to better manage their soil? Could be anything preventative, applying fertilizer, whatever you want, Lynn, go.
I think that the growers in Australia have a really good sort of intimate knowledge in terms of what's going on across their paddocks and where they do have good performance and poor performance. And to me, you know, understanding that poor performance is really important before jumping into a management solution. And as much as we look to identify what the problem is, I think it's equally as important to eliminate issues. And that, you know, relates to the pH issue, for example, that we were talking about earlier. You're not necessarily looking or testing to find a pH issue, but if you test to eliminate that, then it opens up more targeted options that are more likely to work. I was maybe a little bit confused, but we don't always have to have the full answer of what's going on. It's as useful to eliminate what's not going on.
Right, it's very insightful. Dr. Lynn Mcdonald, thank you very much for joining us today. That was absolutely awesome. I think I certainly learnt a lot out of this, and I hope our listeners did too. So yeah, look, thanks very much. We'll post this online. People will be able to watch this again. We'll share it around on socials, and really appreciate your time, Lynn. Thank you very much.
Well, a big thank you for having me on, and yeah, I think we've had some really good chats in the run up to this as well. So thank you.
I think so. Thanks all.